Hi, so welcome back to the second episode of this series. In the previous episode, we took a look at the set of natural numbers, which is a set of all positive whole numbers which are greater than 0. In this video, we're going to take a look at the set of integers. The set of integers contains all of the positive and negative whole numbers, including 0. The set of integers is denoted by the letter Z. Since the set of integers contains all of the positive and negative whole numbers, we use an ellipsis on either side of the curly brackets to tell us that the set continues to infinity. This can also be denoted by placing an arrow at each end of a number line. Now that we have defined the set of integers, we can now learn about multiplication and division of two integers. The results of multiplying and dividing numbers vary depending on whether a number has a positive or a negative sign. When you multiply or divide two numbers with the same sign, you get a positive result. For example, if you divide minus 15 by minus 5, you end up with plus 3. This is the same as saying 3. Another example would be multiplying minus 3 by minus 5. Here we get plus 15. This is the same as saying 15. An obvious result which I won't write down is multiplying or dividing two positive numbers. Since their signs are the same, you get a positive result. When you multiply or divide two numbers with different signs, you get a negative result. For example, dividing minus 15 by 5 gives minus 3. The same is true if the minus is swapped between the numbers. For example, dividing 15 by minus 5 gives you minus 3. And again, by multiplying minus 3 by 5, or 3 by minus 5, we get minus 15 as a result. So to conclude this section, we can say that multiplying or dividing with the same signs gives us positive results, and multiplying or dividing with different signs give us negative results. Here is a Venn diagram representing what we have looked at so far. Venn diagrams are very useful in illustrating how different sets interact with one another. In the previous video, we had a look at the natural numbers, which is shown here by the blue circle. The set of integers is shown here with the yellow circle. The set of integers contains every single element of the set of natural numbers. This has been shown in the Venn diagram by placing the ring representing the set of natural numbers inside the ring representing the set of integers. We will cover the sets of rational, irrational, and real numbers in future videos. Now it is time to take a look at the order of operations. The order of operations tells us in which order different operations should be applied to a sum. Operations are just mathematical processes. For example, multiplication, division, addition, or subtraction of numbers. The order of operations can be memorized by using the acronym BEMDAS, which stands for brackets, exponents, multiplication, division, addition, and subtraction. Whenever we are dealing with more complex sums, we can use the order of operations to apply each operation in the correct order. Here is an example of a sum in which we would need to use the order of operations. In this example, we have to deal with the addition and the division operators. By taking a look at the acronym, it can be said that division is the first operator that should be used within this sum. So to begin, we must divide 32 by 2, which leaves us with 16. Replacing the original sum with our answer, we are left with 9 plus 16. Now, the only operator that is left is addition. By applying the addition operator, we get 9 plus 16 is equal to 25, which is our answer. Here is another example where the order of operations is necessary in finding the correct solution. It is easy to see that the brackets is the first operation that we must calculate. By calculating what's inside the brackets, we get 3 plus 3 is equal to 6. Replacing this in our original sum, we end up with 5 multiplied by 4 minus 18 divided by 6. We don't have any exponents in this sum, so the next on our list is multiplication. Multiplying 5 by 4, we get 20. Now we can update our sum. We do this by replacing 5 multiplied by 4 by 20. Here we have 20 minus 18 divided by 6. The next operator on our list is the division operator. Since division is present in our sum, we must use the division operator to calculate 18 divided by 6. Here we get 18 divided by 6 is equal to 3. Replacing 18 divided by 6 with 3 in our sum, we find ourselves left with 20 minus 3. The only thing left for us to do is subtraction. By calculating 20 minus 3, we end up with 17. The final example uses every operator except addition. By the order of operations, we must calculate the brackets first, and in this example we have two sets of brackets to deal with. By calculating the contents of each bracket, we get 5 minus 3 is equal to 2 and 6 minus 2 is equal to 4. Now we can update our original sum. Here we have 4 multiplied by 2 squared divided by 4. The next operation on our list is calculating the exponent. An exponent is a power that a number is raised to. So in this example, 2 is raised to the second power. This means we multiply 2 by itself. Or, in other words, we take the square of 2. More information on exponents will be found in a future video on a chapter named Indices. Taking the square of 2, we get 4. This is because 2 multiplied by 2 is equal to 4. Now we can replace 2 squared by 4 in our original sum. Next on our list is multiplication. Instead of using a multiplication sign, here the number 4 beside the bracket indicates that we are multiplying 4 by 4. Any number placed beside a bracket means that the number is being multiplied by everything inside that bracket. So in this example we have 4 multiplied by 4 because 4 is inside the bracket. In the case of two brackets beside one another, everything inside each bracket is multiplied by each other. So multiplying 4 by 4, we get 16. Updating our original sum, we can replace 4 multiplied by 4 by 16. Now, the division operator is the only one remaining. So calculating 16 divided by 4, we get 4. So before the end of the video, I just wanted to make a quick note about exponents. In the previous example, we seen that 2 squared is equal to 2 multiplied by 2, which is equal to 4. Recall here that two brackets beside one another means multiplication. Now squaring minus 2, we see that it gives the same answer. This is because, if you remember back to the very beginning of the video, we said that two numbers being multiplied by each other with the same sign gives us a positive result. One thing to be wary about is where the negative sign is when squaring a number. Brackets are not always a necessity when writing a number to the power of another number. But in this case, on the third line, you can see that if a negative is placed outside of the bracket, we end up with minus 4 instead of 4. This is because the number being squared is 2, not negative 2. So in this case, the square is being applied to 2. So we get 2 multiplied by 2 is 4, and then the minus is applied to the 4. So our answer is minus 4. As a result, we can say that the first and second lines are equal, but they are both not equal to the third line. Thanks for watching this video. In the next video, we will take a look at rational numbers and addition, subtraction, multiplication and division of fractions.